Good morning, class. Let's begin with a fun challenge to warm up our minds. On the board, you'll see three technology items: a computer mouse, a USB flash drive, and a smartphone. Each one represents a number, and your task is to figure out what each is worth. Now, if 3 computer mice together equal 36, and 1 mouse plus 2 USB flash drives equal 28, while 1 USB flash drive minus a smartphone equals 3, then what is the value of a mouse, a USB flash drive, and a smartphone? Very good. Our answers are mouse equals 12, because we have just divided 36 by 3, and it is equal to 12. USB flash drive equals 8, because 12 plus 2 with the same unknown value is equal to 28. So 12 plus 8 plus 8 equals 28. And smartphone equals 5, because a USB drive is 8 minus with an unknown value of a smartphone is equal to 3. So 8 minus 5 is equal to 3. Yes, excellent work. You solved the puzzle using reasoning and logic. Now let me ask you, what kind of numbers did we use to solve this puzzle? Yes, they are whole numbers. And if these are whole numbers, what bigger idea in mathematics do they belong to? That's right, the number system. So today, our lesson will be about identifying the number system and exploring the different types of number systems that help us represent values in mathematics.
Now, let's go with our next activity, called Mix and Fix Math Words. I'll show you some scrambled letters, and your task is to figure out the correct word. Our first set of letters is B-E-R-N-U-M. Can anyone guess the word? Yes, it's number. Are you familiar with this word? Yes, very good. Numbers are symbols we use to count, measure, and label things in everyday life and mathematics. Now let's try S-T-S-M-E-Y. Rearranged? Very good. It becomes system. Do you know what a system means?
Yes. A system is a group of connected parts working together. And in math, number systems organize how we represent and work with numbers. Next, we have N-A-R-Y-B-I, which forms the word, yes, binary. Have you heard of binary before? Very good. Binary is a system that uses only 2 digits, 0 and 1. And it's the foundation of computers and digital technology. Moving on, T-C-L-O-A. Yes, it becomes octal. Are you familiar with the octal system? Yes, it is based on 8 digits, from 0 to 7, and is sometimes used in computing as a shorthand for binary. Finally, we have A-M-L-I-D-E-C. which rearranges into... Very good, it's decimal. Do you know what decimal means? Yes, the decimal system is the one we use most often, based on 10 digits, from 0 to 9, and it's the standard for everyday counting and arithmetic. By solving these puzzles and reflecting on whether you know these words, you've uncovered the key number systems we'll explore further in our lesson. Now, humans communicate using words, letters, and characters. We are naturally accustomed to working with language and numbers in everyday life. However, computer systems cannot directly process this kind of data. They can only understand and accept information in the form of numbers or machine language. If we think back to our mix and fix math word activity earlier, we realize that solving it would not have been possible without first decoding it. Understanding the hidden meaning behind the puzzle is what allowed us to arrive at the correct answer. In computing, different number systems are used by computers to represent and process data. The main number systems are binary system, octal system, decimal system, hexadecimal system. Which of these number systems do you encounter most often in everyday life? So, in everyday life, the decimal or base 10 system is the one you encounter most often, as it's the standard for everything from counting money and reading prices to checking the time or speed limits. While binary and hexadecimal are essential for the devices you use, they usually stay hidden behind the scenes. You might only catch a glimpse of hexadecimal when seeing a hex code for a specific color in a design app, or a MAC address in your phone settings. But for almost every physical interaction, decimal is the universal choice.
Remember, the choice of number system depends on the application and the needs of the computer system. And if you were designing an app, which number system would you choose and why? If I were designing an app, I would primarily use decimal for the user-facing interface because it's what people understand. But I would rely on hexadecimal for the actual development process. Hexadecimal is the ideal middle ground for a designer or programmer. It is much more compact and less error-prone than binary, yet it translates perfectly to the computer's native language. For instance, using a 6-digit hex code to define a background color is far more efficient than managing a string of 24 ones and zeros.
In short, number systems allow us to represent numbers using a small set of symbols. That's why we can think of number systems as the computer's language. Different systems are used depending on the situation. In mathematics and computing, we use different number systems to represent values. The most familiar is the decimal system, or base 10, which uses digits 0 to 9. For example, the number 345 is written using decimal digits. Computers, however, rely on the binary system, or base 2, which only uses 0 and 1. In binary, the decimal number 5 is written as 101. To make binary numbers easier to read, we sometimes use the octal system, or base 8, which uses digits 0 to 7. For instance, the decimal number 10 is written as 12 in octal. Another system widely used in programming is the hexadecimal system, or base 16, which uses digits 0 to 9 and letters A to F to represent values. For example, the hexadecimal number 4B5 equals the decimal number 1205 because 4 times 16 squared plus 11 times 16 to the first plus 5 times 16 to the 0 equals 1024 plus 176 plus 5, and it is equal to 1205. Each system has its own purpose: decimal for everyday life, binary for computers, octal and hexadecimal for simplifying digital work.
Now, let's take a moment to recall what we've learned about number systems. What do we mean when we talk about the binary system? How do we define the octal system? What is the decimal system that we use every day? And finally, how do we describe the hexadecimal system? Now, which number system uses letters? Why is the binary number system used in computers? How many unique digits does the decimal number system use to represent all the numbers? And what is the purpose of using different number systems in computers?
Now, this organizer is designed for our topic on the number system and its different types. Please complete each section with the key concepts we've discussed, and then write a short reflection or takeaway in the space provided below. Good luck! We've seen how to identify different number systems and their uses. Thank you for watching. I appreciate your time and hope you learned something valuable today.